A very good morning, students. Let's continue learning our lesson number 3, current electricity. So in today's lecture, we are going to learn more new concepts. The first one is conductors and insulators. We have learnt about the resistance to an electric current. We can divide substances into conductors and insulators, that is bad conductors. Those substances which have very low resistance are called conductors, and current can flow easily through such materials. Insulators, those substances which have extremely high resistance and through which current cannot flow, are called insulators. So, what is the difference between conductors and insulators? Conductors are those substances which have very low resistance, are called conductors, and current can flow easily through such materials. And insulators are the substances which have extremely high resistance and through which current cannot flow easily, are called insulators. So students, moving to the next concept, there is numericals based on resistance and Ohm's law concept. In our previous lecture, we have seen what is resistance and Ohm's law. So on the basis of that concept, now we are going to solve the numerical. The example number 3. So what's the question? A current of 0.24 ampere flows through a conductor when a potential difference of 24 volt is applied between its two ends. What is its resistance? So students, in this numerical, current is given and the potential difference is given. We have to find out the resistance. So first step, to write all the given things. What is the given things? That is V, and V is the potential difference, which is equals to 24 volts. The unit of potential difference is volts. I is the current, which is equals to 0.24 ampere. A stands for ampere. The unit for current is ampere. Next, what's the formula to find out the resistance? Recall it, students, fast. The formula for resistance is equals to V upon I. So, resistance is not given. Substitute the value. V is given as 24 volts and I is given as 0.24 ampere. So, now here it is mathematical calculation. When we have to remove the decimal point from the denominator's place, what we do? We add 0 in the numerator place. So, the decimal point is before 2 digits. So, we have to add 2 zeros in the numerator place. So, when we remove the decimal point, when we add 2 zeros in the numerator, it becomes as R is equals to 2400 divided by 24. So, when we do the division, 24 ones are 24, 24 ones are 24 and 20 as it is. So, our final answer comes as 100 ohms. So, the resistance of the conductor is 100 ohms and the unit for resistance is ohm. That's why the answer came as the resistance of the conductor is 100 ohms. Now solving the next example. What is the question? Let's see. Determine the current that will flow when a potential difference of 33 volts is applied between two ends of an appliance having a resistance of 110 ohms. If the same current is to flow through an appliance having a resistance of 500 ohm, how much potential difference should be applied across its two ends? Now students, in this numerical, two cases are given, two conditions. The first case is, first write the given things. What is given? V is given as 33 volts. Potential difference is given as 33 volts when the resistance applied is 110 ohms. So in the first case, we have to find out the current. So I is equals to V upon R. To find out the current, the formula is I is equals to V upon R. So V, the value of V is 33 and R is given as 110 ohm. Now here mathematical calculations come. We have to divide 33 by 110. 33 is a 2-digit number, 110 is a 3-digit number. So first we have to make 33 a 3-digit number. So what's the step to do this? We add a decimal point and add a 0. So what we do? Decimal point and 1 0 in the numerator's place is added. So sums becomes as 330 divided by 110. Then 0 0 gets cancelled and 11 ones are 11, 11 threes are 33. So write 3. So what the answer come as? It comes as 0.3. So what is 0.3? It is the current, that is I is equals to 0.3 ampere. So first case is solved. So current flowing through the appliance is 0.3 ampere, where the potential difference was 33 volts and resistance was given as 110 ohms. In the second case, we have to find out the potential difference where I is given as 0.3 ampere and resistance is 500 ohms. So here we have to find out the potential difference, that is V. So what's the formula? V is equals to I multiplied by R. So our I value, current value we removed in the first case is 0.3 and R is given as 500 ohms. So while multiplying, what we are going to do? We have to multiply 500 multiplied by 0.3. So what answer comes? When we multiply, answer comes as 150.0. So the required potential difference between its two ends is equals to 150 volts. The potential difference is measured in volts. That's why the unit we'll write as 150 volts. So the answer comes as the required potential difference between its two ends is equals to 150 volts. Moving to next concept, that is system of resistors and effective resistance. A resistor is a two-ended component having a given amount of resistance between its two ends. In several electrical devices, a number of resistors are connected together in different ways. Ohm's law is applicable to all such connected resistors. Resistors in series. Study the figure. You can see that the ends of the three resistors are connected so that they follow one after the other in a single line. These resistors are said to be connected in series. In such an arrangement, the same current flows through each resistor. The value of current is I and the potential difference between C and D is V. The three resistors, that is R1, R2 and R3, are connected in series in the circuit. Let the voltages across them be V1, V2 and V3 respectively. V is equals to V1 plus V2 plus V3. Equation 1. If Rs, that is S for series, is the effective resistance between C and D, then according to Ohm's law, V is equals to IRS, where S stands for resistance in series. So V1 is equals to IR1, V2 is equals to IR2 and V3 is equals to IR3. Substituting all these in equation 1, we get as IRS is equals to IR1 plus IR2 plus IR3. So RS is equals to R1 plus R2 plus R3. If n resistors are connected in series, then Rs is equals to R1 plus R2 plus R3 plus it becomes at the end, that is Rn. if resistors are connected in series, the same current flows through each resistor. The effective resistance of the resistors is equal to the sum of their individual resistances. The potential difference between the two extremes of the arrangement is equal to the sum of the potential differences across individual resistors. The effective resistance is larger than each of the individual resistances. This arrangement is used to increase the resistance in a circuit. So students, this was all about today's lecture. What all concepts we learn? First, we learn what is conductors and what are insulators. So what is conductors? Those substances which have very low resistance are called conductors. That means current can flow easily through those substances. And what are insulators? The substances which have extremely high resistance and through which current cannot flow easily are called insulators. Next concept, we solve the numericals on the basis of Ohm's law and resistivity. Then we saw the concept of resistors in series. What is series? When all the resistors are connected in one line, then it is said to be as resistors in series. In our next lecture, we will be solving the solved examples for resistors in series, and also we will be learning the new concept, that is resistors in parallel. Till then students, watch the video attentively to clear all the concepts. Thank you children for your attention. Goodbye. Have a beautiful day.